Hi, and welcome to the Machine Learning Toolkit 4.2 update. It's March 2019. We have a ton of new content that's all about the top customer asks. First, we have a density function algorithm that's been added to the Machine Learning Toolkit for easy-to-use numeric outlier detection with an auto-detection of what is normal and what is not. So you can still specify specific math interactions with it, but you can also just run it in auto mode, and I'll show you that here in a moment. We've also added a Statespace algorithm, so it's for easy-to-use forecasting with the Machine Learning Toolkit for scalable and customizable forecasts, delivering many common customer asks like special days, like holidays, like Black Friday effects, etc., and multivariate forecasting. We've also added the Independent Component Analysis, ICA, pre-processing step, which is generally used for separating overlapping signals like voice recordings in a crowded room. We've added a new visualization, the 3D scatter plot, which is a super popular visualization from Splunk that everyone was already using to look at the different clustering outcomes from the toolkit. We've brought that into the toolkit and added a bunch of enhancements that customers have asked for, like drill downs and being able to control the different color features. We've also added a new app to Splunk that's the Splunk MLTK algorithms on GitHub. It's an easy way for you to install and use the community algorithms from our contribution GitHub without actually having to download the GitHub directly. You can just install it directly as an app. And we updated the two apps, the ML-SPL Performance app, which has all the performance metrics that you might want from the different algorithms the toolkit ships with, as well as the Python for Scientific Computing. We've updated that to version 1.4, updating the machine learning runtime for all the goodness that's come out in the last 6 months or so from open source, etc. And you're going to want to update Python for Scientific Computing for every new version of the toolkit moving forward. So 4.2, 4.3, etc. will need the new version of Python for Scientific Computing. So the first thing I want to dive into is the density function algorithm. So it's really intended to be an easy-to-use numeric outlier detector with a bunch of auto features to be able to detect what is normal and what is not across all the different densities, the different observations in your data. Please check out the What's New in Machine Learning Toolkit blog 4.2 for an XML dashboard you can download. I'm actually going to go through a couple of quick steps here and show you it. So I'm going to start with a copy of Splunk running here on my laptop. It's got all the apps that I'm using from Splunk that I've installed. One of those is the Machine Learning Toolkit. Now, the Machine Learning Toolkit comes with a whole bunch of features. I'm not going to dig into each one. We're just going to look at the new algorithm density function first. So I'm going to click on my docs link. I'm going to go to my user's guide. In my user's guide, I have a section called algorithms, so I'm going to click on, and I'm going to go straight to the section that has the density function, which is anomaly detection. And there's the hot link for density function. So density function is all about providing a easy-to-use anomaly detection out of the box across a large set of data where you have a whole bunch of different things you're trying to observe and you want to observe them differently and be able to get the right values for it. You know, it's really about getting brilliant alerts quickly. So I actually wrote a blog about a year or so ago called Cyclical Statistical Forecasts and Anomalies, and I talked about how you can use Splunk to build anomalies and quickly alert on those anomalies in a meaningful way. And the SPL was a bit long, right? It was a bit long. It had all of these different features, and then it had you picking math, you deciding that you're going to treat every hour of day, every minute of hour, every day of the week, you're going to treat them all as a normal curve. You're going to assume that standard deviation and average are the right things to use. Well, instead of having you pick the pieces of math, let's have machine learning pick the pieces of math. So when we look at the example and density function, just scrolling straight down through all the different options you can choose, we actually have some easy-to-use out-of-the-box examples. So we're going to take this first one that uses the same data sets, in fact, the same use case as what we saw from the blog post. But now instead of you setting the math, you setting standard deviation and average, you deciding that everything is a normal curve, we're going to have machine learning learn the correct curves, learn the correct things that are normal and not normal for you. So I'm going to copy that search. I'm going to go straight to a copy in my Machine Learning Toolkit, a search bar in my toolkit where I'm going to paste that search in, and I'm going to run that search. And while that search is running, you can see we've got that call center data with the different lines of business that are coming in. We're extracting a bunch of features, things that we care about, like the hour of day, the day of week, etc. And then we're counting the total number of calls that come in for each one of those things with a by clause there. So we end up with this long set of data that really tells us, on each day, on each hour of day, on each bucket minute of hour, for each of the different sources, each of the different inputs to our call center, what were the number of calls that came in. And then we fit our density function. We fit our density function. We have a new section with a by clause in it. That's the first time we've had a by clause in the fit command, where we're telling density function to look across my data and consider these different time slices, consider these different observations and all the different combinations. And we persist that into a model. And if we scroll down slightly, we see that we have a new field called isOutlier. We've got some boundary ranges that have been discovered from our model, and we can quickly sort those outliers and discover where we have an outlier based on some sort of curve. But it's actually a lot more complicated than that. Under the hood, we've actually processed all of these events and really discovered all the different curves. So I'm going to show you that by selecting the name of my model. It's just my model. I'm going to go to another search, and I'm going to say summary, my model. So instead of seeing that every section in time has been discovered as a normal curve, instead we've actually detected all of the different combinations and decided behind the scenes with machine learning, what is the appropriate density? What is the appropriate math to use? And we actually can see that a lot of this is coming in as auto Gaussian. And some of it shows up as exponential, and some of it will show up as auto-normal, but you're not actually deciding that each one of those curves is predetermined to be normal or predetermined to be Gaussian. We're actually discovering that for you. So you can go right back to any new incoming data and quickly change that to apply my model to get all of those different values that you saw in the original blog, all those different anomalies that are detected from the different curves. You instead get those automatically by just applying the model back to new incoming data. And here we are. The isOutlier is defined right there. You can interact with this algorithm. You can control percentages, and you can constrain the auto feature. So instead of allowing it to pick exponential, you can make it only pick normal distributions if you want. But out of the box, this will automatically process data and tell you about what is normal and not normal. It will fit into the fit and apply context, so you can easily process a large period of historic data and then use that model on disk to apply to real incoming data, real-time incoming data, and take action, just like the blog series. So moving right along, we've also added a Statespace algorithm, a forecasting algorithm that will quickly learn your data and give you a scalable and customized forecast, a projection into the future, with a lot of common customer asks. Things like, I want to be able to add special days or holidays, for example, to my forecast so that I can forecast through Black Friday, or I can forecast through a Fed meeting, or any kind of special day that affects your business, right? An easy way to add those so that the algorithm can adjust its prediction based on those values. And also another thing that customers kind of want to do is they want to do some multivariate forecasting. They want to forecast multiple values into the future all at the same time and have the different periodicities actually interact with each other and create a more richer forecast into the future. So, in the past, we've had the predict command. That's the graph on the left where it learns the curve through time and then projects into the future. Smart forecasting, on the other hand, using something like Statespace Algorithm, makes a projection kind of like what we see on the right, where it learns the curves through time and more closely fits that prediction into the future. I'm going to show you a quick example, but you will have a full XML example in the What's New in Splunk Machine Learning Toolkit 4.2 blog. So I've taken the simple XML dashboard I just mentioned, I've preloaded it up. You'll be able to download it and view it as soon as that blog goes live. So first I start with a business problem that I'm trying to solve. Like I've got 5 weeks worth of logins right here, and I want to forecast what my likely login patterns are going to be for the next 3 weeks, right? And I can look at this pattern, and as a business owner of this particular system, I can see that I want a 7-day forecast. I want to make sure that Sundays are treated like Sundays, Mondays are treated like Mondays. I have a cyclical business process, 7-day business process that I want to project. So the first thing I do is I take that data in Splunk and I try the predict command. And the predict command does an okay job. It learns the overall trend and projects the trend into the future, but it's not very detailed, right? This is my predicted logins. This is my upper threshold. This is my lower threshold. That's a big envelope of possibilities for the next 3 weeks. I need something more exact. So smart forecasting using the Statespace algorithm out of the box does a much better job. We can see that it's learned the zigzagging pattern from the past, and it's projecting that pattern into the future. Looking much better, but still not quite right? I can't see Sunday and Monday so clearly in my future. But because I'm using fit and apply, I can actually examine what is the model file. That's this part. What is the model file? And I can say, hey, what is Statespace detecting as the highest periodicity? And it's actually detecting a periodicity of 284. So it's basically saying that every 284 minutes, it's 284 time slices, I should say. It's detecting a pattern that it's projecting into the future. I actually wanted to, my business problem was, I wanted to detect a 7-day business cycle. So I'm going to quickly override it. I'm going to say, that's a great detection there, but I want to override you with an actual periodicity that is the 7 days. And in this case, the period for 7 days, because every slice is 5 minutes, that's 216 5-minute slices per 7 days. So I override the forecast with the 216, and I get a forecast into the future that looks really good. I can see that these are the weekends. I can see the weekends are trending upwards as we go forward, like there's an overall upward trend. But we can also see that Mondays and Saturdays and Sundays and Fridays, every day of the week, it has a distinct pattern going into the future that it's learned from the past. Now, in addition to that, Statespace is also multivariate, so I can forecast many things going into the future, right? I can forecast both the logins, I can forecast the app usage, I can get both of those things into the future and how they interact with each other into that projection into the future. So now I've got multiple values being forecasted in the future together and how they interact. And of course, I also have some other great options I mentioned before, like holidays. I can actually insert a holiday and have it detect a holiday. That right over here, we can see a holiday where the pattern is actually broken. It's no longer 5 days of perfect curves. It's actually 6. The 6th day has an extra hump on it, an extra shift upwards because we've added a holiday to tell the forecaster that we should expect an unusual kind of behavior then. So that's the idea behind Statespace. It's all about giving you customizable, easy-to-use forecasts out of the box. I'm going to briefly touch on a few other items. We've added a new 3D viz, that's the 3D scatter plot. There's an example in the docs that you can just go in there and quickly slap that into a search and show the visualization of clustering with that new 3D scatter plot. Unlike the one that's already on Splunk base, this one is actually now part of product and has a bunch of new features, including drill down. You can click on any one of these and drill into the actual event that it occurred, as well as a bunch of options that customers are asked for, like the ability to control colors, and being able to actually interact with the different formatting options for the clusters. We've added a new app on the Splunk base. This is all about your ability to now take that GitHub filled with the contributed algorithms of the last 6 months or so, be able to take all those contributed algorithms and easily insert them into your own copy of Splunk. So the Toolkit has an extension piece on the back that exposes a data frame for people to write custom Python to and register net new algorithms to your own localized copy of the Toolkit. The GitHub community was all about people contributing up to that space. So we have a small community of writers who wrap additional algorithms as they find it useful and insightful. These are only open source ones, and they're uploaded to GitHub, and now we've made that available as this additional app on Splunk base instead of you having to go through the GitHub installation. Finally, we've updated the ML-SPL performance app, and we've updated the new Python for scientific computing app. So the ML-SPL performance app on Splunk base is all about giving you some easy to use metrics about what the impact of using different algorithms on your Splunk infrastructure are. And the Python for scientific computing is our runtime for machine learning. So that's the sister app that the Toolkit connects to run all the different algorithms in. It's also the app that some of our partners write additional content on top of. We update this app approximately every 6 months with all the goodness and awesomeness that comes from open source, so that you have at your fingertips a safe and easy to use machine learning runtime environment for your development, as well as for leveraging through the fit and apply context of the Toolkit. Thank you for your time. I really hope you enjoy the Machine Learning Toolkit 4.2. Please write in if you have any questions or comments.